In this video, I will explain how I will teach Faraday's law and Lenz's law in my class. At the beginning of the class, I will show them specifications. The purpose of showing specifications is to let students understand what we will discuss in the class. And this is also one way to attract their attention so they can understand we're going to talk about new concepts so they can focus on the class. But I will not explain them a lot about these contents. At the end of the lesson, I will go through these specifications again so they can check their understanding. The purpose of this slide is to connect their previous understanding with new concept. They have already studied about electricity, that electricity can produce magnetic field. Here I will ask them, can we produce electricity from magnetic field? I will give them about 1 minute. And then I will ask them to explain the answers with reasoning. In this way, by listening their reasoning, I will be able to figure out the common misconceptions. And then when I will explain Faraday's law, means electromagnetic induction, I will focus on those misconceptions. Here we will talk about history of electromagnetic induction. Why it took 10 years to figure out that magnetic field can produce electricity. So we will discuss about history of EM induction, how this was developed. By connecting student with the history, how the concept was developed is very important to engage student and to enhance their interest in the subject. And this is main purpose of this slide. With the help of this animation, I will let student see and also I will let student feel that we can produce electricity without battery. By simply moving a wire in a magnetic field, if the wire is cutting the magnetic field lines, we can induce EMF. And if it is a complete closed circuit, we can produce current. With the help of this animation, I want them to understand that when the magnet is approaching, needle of ammeter will deflect in one direction. And when the magnet is moving away from the coil, needle will deflect in the opposite direction. When they will observe this animation, it will help them to understand that there is something to do with direction of motion of the magnet and how direction of motion of the magnet is linked with deflection of the needle. I will also show them, I will place a magnet in the coil, in the real experiment in front of the class. I will show them if I place magnet inside the coil, there is no reading. And then I will explain them there is something to do with relative motion, and also we will make short summary. Now student, they have understanding that by moving a wire or by moving a magnet into a coil or moving the magnet away from the coil, we can produce electricity. Now this is time for them to understand how to calculate magnitude of induced EMF, how much electricity we can produce. So I will little bit recap about magnetic flux. They have already studied about magnetic flux, but I will recap this again. So the weak student, maybe they are not very clear about magnetic flux, so they can review again this concept and they can get ready for induced EMF. On the second slide, I will give them this question to make sure they have clear understanding of magnetic flux. I will ask them to do this question, and then if the answer is different, I will emphasize. If they got correct answers, then it's wonderful. After this one, we will go directly to magnetic flux linkage, because understanding of magnetic flux linkage is very important to understand induced EMF, and also very important to understand how to calculate magnitude of induced EMF. With the help of this slide, I want them to connect their understanding of magnetic force with electromagnetic induction, means simply extend that concept, because making connections is very important to understand new concepts. Second slide is also based on this concept. Here I will not introduce Fleming right hand rule. We will discuss this one with the help of Fleming left hand rule. And on this slide, I will connect those last two slides here So they will see the whole picture together. So they will start understanding what is electromagnetic induction. Now I will explain them what is Faraday's law of electromagnetic induction. But I will emphasize on that it is proportional to rate of change of magnetic flux linkage. Rate of change of, that is the main concept. And then also I will introduce this equation, but here we will not talk about direction. The purpose of this animation is to let them see if the magnetic field is changing. So they will be induced EMF. Here they will see when the magnetic field is decreasing. So the main purpose of these animations is to let them visualize, not just simply say. This is also area. If the area is changing, there is also change in magnetic flux linkage. It means there is induced EMF. So here the also area changing mean we can change area by rotating effective area. So they will see, they will constant changing area. So here they will see when the coil is moving in a magnetic field and magnetic field is constant. So the purpose of these things is to let them visualize. Next, here I will ask them question to check their understanding now, because they have studied about Faraday's law. And then I will give them this question, so they should be able to apply Faraday's law equation. So this question is not very hard, but it will help weak student and good student to understand how to use Faraday's law equation to calculate induced EMF. Here I will explain them how to calculate motional EMF in a wire. We will do this derivation because this will help them to understand the factors affecting induced EMF. Until now we have discussed about Faraday's law of electromagnetic induction. We also understand the equation. We have also talked about motional EMF, and also we have done the derivation. Now it's time for students to develop their understanding by applying the knowledge in different situations. So these conceptual questions will help them to develop their understanding of Faraday's law. So we will go through this question. I will be asking them and I will ask them to explain, and based on their explanations I will give them feedback, and also I will help them to correct the misconceptions. So these are questions for that purpose, and this is numerical question. They will also do this one in the class, so this will help them to develop their understanding. After these questions we will go to Fleming's right hand rule. So I will explain them how they can use Fleming right hand rule to find direction of induced current. I will explain them with the help of this example how to apply Fleming right hand rule. Here this example we have already done with the help of Fleming left hand rule. Now we will use Fleming right hand rule. Now student, they have good understanding of Faraday's law. We will move to Lenz's law. I will do these demonstrations and let them observe, and then here I will explain them little bit about this one, what is happening. On this slide, this is the animation. This will combine the previous two slides. Let them start understanding about Lenz's law. So here I will introduce Lenz's law. I have already underlined this one. Opposes the change in magnetic flux linkage. So I will also explain that with the help of this one. Change in magnetic flux produce EMF, then EMF induced opposes the change in magnetic flux. And we will also redefine Lenz's law again here. So this will help them to understand. So here we will be talking about conservation of energy, and here we will combine Faraday's law and Lenz's law. And finally we will talk about some conceptual questions here. So these are all conceptual questions. This is question from past papers. Very important to use Faraday's law and Lenz's law. After we will talk about some applications of Faraday's law and Lenz's law. This is, I will do this demonstration in the class. I will drop a magnet through a plastic pipe and also through a copper pipe, and also I will ask them some questions. I will ask them to explain how they will explain, and then I will explain. So here I will ask them some questions based on that demonstration. And here we will talk about a little bit about these curves, EMF against time graph, and I will ask them some question. And here EMF induced between two coils. Very important concept. I will give them this question first, let them explain, then I will explain. And finally This demonstration will be done by students, and this will be a homework. They will do this demonstration in the class, and they have to write down explanation by themselves, and I will explain this one in the next class. At the end, I will show them the specifications so they can see do they have good understanding of these concepts or not. That's all for this class.